So I thought that in this video we could try to use ChatGPT to learn some OpenGL. So can you help me learn OpenGL? I am working on a Linux machine and would like to use C or C++. Okay, so it generated something, but as sometimes happens, it didn't really finish. So we can say you didn't finish explaining step 2. Please do so. And then it will say, sorry, here I go. So I'm not sure exactly what happened now. First of all, it said 1. I don't know if that's just because it's not highlightable, so I think it's maybe it's not that it has written 1 dot, it's just that like this is a list element. And yeah, I think so. So anyway, it made a make file and some project structure and whatnot. So let's see what it has said. So first, install the necessary libraries and tool. You need to install development libraries for OpenGL, GLFW, and GLAD. So let me see, how can I check if, I think it's whether I have OpenGL and GLAD already installed. So it might just be a command like this, but I'm not really sure what it is. So let's see what it says. Okay, so let's have a look. So first it says check OpenGL. Let's see if this even runs. So it did run. I don't know what exactly it does. So we have some version, 4.6, that seems fine. Now let's check GLFW, should be like in user include. So let's see if there's a GLFW. There is such a folder. That's amazing. And to check, search for the header files, library files in your system. The headers are found here. I'm not sure. I'm gonna try to run this just. Okay. Okay, whatever. So I guess these are hopefully the right headers. Let's see if it says anything about the version. It does not say anything about the version. For the library files, so let's look at that. And then there should be, let's just search for anything with this. It was not there, so maybe it's in local. Also not. Okay, I guess I can try this command. Okay, so it is somewhere like under this one. So I guess that's fine. And this GLAD is then not a library like this. It's a source and header file generated based on your OpenGL thing, blah, blah, blah. So I know of a website where you can learn OpenGL. It's kind of geared towards Windows as far as I can see, but let me check what that one says, because this link looks a little bit weird. Okay, so this learn OpenGL linked to the same thing. So let's get that. You need to download and include these files. You can use the website generator as mentioned in the previous response. So let's see what it said here. Go to the configure the generator as follows. Nice. Language, yes. Specification, yes. Profile, core. API version 4.6. Options, generator loader, and click generate and download the generated glad.zip file. So we have that. Extract it and you'll find two folders, include and source. Okay. All right, so I've done this. We now have some include folder. Let's say like this, I think. No, like this. It doesn't, why doesn't tree work? Okay, now it works. Just don't know the commands, but whatever. So anyway, we have the zip folder which unpacked looks like this. So let's look here now. There's some code. Let's skip that. And let's go into this one, which I noticed when it explained me how to build it and run it. It assumes the structure looks like this. So we have a project, sure. Then let me just remove this one because it's a bit annoying. Clear tree. Okay. So we have some project. We have include. It has glad.h, has khr platform.h, source, glad.c, and then we can say let's get a main file, and there we go. So that looks correct. Let's see now if we can actually get this to run. So we want to look into the main, and we should, as always, so this does not work because it doesn't know about the that has to include from the include folder, which is this flag in the makefile. But I guess, what if we do like this? Then it doesn't complain and we don't need this flag in the... So I will do this just to make my editor happy. But anyway, so first we declare some kind of callback, which from the name it has something to do with resizing. Then there's the main function, and maybe we should put void here so it doesn't accept any arguments, because I think if you have this in C, it means like nothing in here. It means it's actually variadic. It can accept any number of arguments. So let's try to put void. Then there's the usual thing. We try to init this glfw, and if it fails, we return -1. Create a window mode window, and it's OpenGL context. So there's something about hints. I don't know what that means. So let's ask, what is the purpose of the glfw window hint function? So let's wait and see what it says. Okay, so let's have a look. glfw window hint is a function provided by this library to set various window and context creation hints before creating a window. Hints are used to specify properties and behaviors for the window. So to me it sounds like it's more of a setting than a hint, but whatever. So here are some common hints and the purposes. So version major, version minor. It specifies the major and minor version numbers of the OpenGL context. That's great. And we also have this one, glfw OpenGL profile. Specifies the profile, which is, yeah, which functions are supported, I guess. So just the core or core undeprecated. And then there's some other stuff which I will skip. So it's basically a way of putting settings. Now, one thing I noticed here is this example set hints to create an OpenGL 3.3, but so the major is the first three, and the minor is the second three. We actually have 4, 6, right? So let's try that. Anyway, so let's keep reading this function, this code. Then we create a pointer to a window, and if the pointer is null, then actually just to be completely clear, maybe we can do this. Then we print an error and we terminate. Make the Windows context current. So what does that mean? What does the function glfw make context current do? Please give as concise an answer as you can, because I don't want all this wall of text and an example that kind of was necessary. Actually, I guess it gave me some information. So it's a glfw function that makes the specified context associated with the current context for the calling thread. All OpenGL context called by the thread now apply to this context. Okay, so it's like we are saying that when we run OpenGL code, it should be on this window. Okay, load the OpenGL function pointers using glad. Sure. Makes sense. Set the viewport. That also makes sense. It's kind of where you're viewing from in relation to the coordinates that you're rendering. Set frame buffer size callback. So it's setting this function as the callback, but when is it called? So let's ask that. When is the frame buffer size callback called? Okay, so it's kind of what I expected. It's like a resize thing. I should have told it to be concise. Okay, it was okay. So this can happen when it be resized, or you change the resolution. glfw automatically updates the frame buffer size when the window size changes, and the callback is then invoked to let your application know about the new dimensions. This allows you to react. Great. So when it should not close, then we ask for a key. I guess this is like non-blocking, so it just looks at the latest, and maybe there's like an option for like no key is pressed, because you don't want this to like block, I would say. Then we do this. So let's ask, what does GL clear color do? Give a concise answer. Sets the color used to clear the color buffer. Sets the color used to clear the color buffer when calling text for arguments. So from now on, please give a concise answer unless told otherwise. So this is not very concise. You should just have said understood, but whatever. What does it mean to clear the color buffer? Because why do you, if it's clearing, to me it sounds like it's setting it to 0 or like to a none value, but here you give it a color. Yeah, so clearing for some reason means resetting it to a specified color. Effectively erasing in preparation, okay, effectively erasing the previous frame's drawn content in preparation for a new frame, okay. Whatever, and this what is this bit then? What is the meaning of the argument to GL clear? Okay, so it means that there is a lot of buffers. For example, these 3, and you use this bit as a mask to tell you which buffer to operate on. So I can clear the color buffer, I can clear the depth buffer, a stencil buffer. So that makes sense. Then you swap windows. This is something if I understand correctly, you often use 2 buffers. One that is you use to calculate the new frame and one that's the old frame, and then you swap those 2 when you want to render the new frame. And here it's asking for events. So we can ask something like, is glfw get key blocking? Just to make sure we understand. Okay, how about okay. So then once you exit out of this main loop, then it terminates and you return. And if the window is resized, then it just changes the viewport to the new dimensions. So that's great. Let's go back up here. And now we have the code, it makes sense. Let's now compile and run it. We have set up GLAD. We have done all of this. We've done this. And now let's make a makefile, which we usually write like this. So let's go through that as well. So the compiler we use is GCC, that's fine. I like those flags. Here it's saying to include glfw, gl, x11, whatever, pthread. So we also have threading, random numbers. Okay, so those flags I'm not familiar with. What is the purpose of the libraries xi and dl? Okay, so it's input. And then there's some dynamic linking, which we need to link with the loader, maybe. Let's ask, because I'm not sure. Why do we need libdl? Okay, so that's when we're loading the function pointers to OpenGL. Great. Let's go back up here. So anyway, so this include thing we don't need anymore. Can make that empty. Then the source, that's fine. Actually, let me take a look. Let me first harpoon that. What is this? So that one's complaining as well. So I will just do Ah, yeah, now we run into some problem. I have to do this. Okay. I don't want to look at this. Then the object files are all the sources where you replace C with O, and the executable is called OpenGL example. And make all, then you try to make this one, and to make that one, you have to make it depends on the objects, and you run this command, and to make the object files, you do this. I'm not sure what this is doing, so let's ask about that. In the make file, what is the meaning of Okay, so $less than is the dependency, and $target is the output, so that makes sense. You compile this and output that. The C flag generate output file. Okay. Great. And what is this .phony? What does .phony do? So it's a special target used to indicate that the associated targets are not actual files, but rather symbolic names for a series of commands. It ensures that the commands for the phony targets are always executed, even if a file with the same name. Okay, so it's if you make a file called clean, I guess, or something, then you still run this. But I think the make file looks great so far. So we have the make file, we have the correct project structure. Now we can try to run it. And it did not work. So let me actually just fix this up, and we'll ignore the fact that it's complaining here, and in the make file we will say include that thing. And now it works, and we have an executable, and if it runs, it actually makes an image or a window. We can resize it. Okay, so that's great. We can do a little bit of OpenGL. So the code works, and we're happy. Can you help me write a basic shader now? Let's try something like that. Okay, so it's given us like a lot of stuff, but here's a basic vertex and fragment shader pair for rendering a simple colored triangle, which is the standard thing you do in these tutorials. I don't really know how this stuff works, but I like know that what you do is you make a color triangle. So let's make a new file that is called vertex shader, as it's suggesting, to GLSL. And we want to paste this in. So I think this is the version, so it should be changed to 4.6. And now let's actually ask it to do something. In the shaders, please annotate each line with a comment explaining what it is doing. Let's try that. Because I think this is telling the compiler where this data is located. So in other places you refer to it as location 0, something like that. While we're doing that. And now it also is telling us that this thing is actually, yeah, the version is this, but I think we should use version 4.6. So let's say 4 and 6. This didn't really explain anything. What? So because I don't really know what a vertex attribute is, so let's ask it what is a vertex attribute. And while it is giving us a great explanation for that, let me make the fragment shader. And same thing here, 4.6. Okay, a vertex attribute is a piece of per vertex data that is passed as input to the vertex shader from the vertex buffer. Vertex attributes usually include information such as position, color, normal, texture, coordinates, and other custom data needed for rendering. The vertex shader processes these attributes and uses them to compute the final vertex position, color, and other data that are then passed down the rendering pipeline. Sure, okay. So basically the idea is you render a set of triangles, and a triangle has 3 vertices and a facet, and on each vertex there can be some data. But this one is running per vertex, and fragment is perhaps per facet. I don't know. So anyway, so what is a fragment? Let's ask about that. In the context of a fragment shader. So let's continue reading. So we get some input variables, which is the position and the color. That makes a lot of sense. Then we declare an output value to pass to the fragment shader, which is just another vector 3. Then we set the vertex position, which not sure what this is. And then we pass the color on, so it's not really doing anything. A fragment in the context of fragment shader is a single pixel-sized data element that is generated during the rasterization process of the rendering pipeline. So there's a lot of things you could ask about here. Fragments include information such as screen position, depth, interpolated data from vertex shader outputs. The fragment shader processes these fragments and determines the final color for each pixel on the screen. Okay, so fragment is kind of a pixel. That's interesting. So again, we set the version, then we get the color, and we output the pixel color. In this case, it's just this. So, okay. Anyway, so now we have this. I'm not just from reading the code and the explanation, it almost sounds like we are only coloring 3 pixels if we have a triangle, but it's probably not correct. Okay, so now we have the shaders in your C code. You can load, compile, and link these shaders into a shader program. Here's a function to help you with that. So let's go to main and create this guy. We don't need to include that one twice. And let's see. So we provide the paths to the source files, and then we're saying open that file and read it. I guess this is reading it. And the same with the, okay, so vertex shader file. Okay, so first we go to the end, we see what is the size of the file. Then we go back to the start. Then we allocate a string to contain all of this. Then we read the contents. Let me maybe zoom in. Then we read the contents. Then we close the file. And vertex shader source. And then the last thing is set to 0 because it's a string. In C, do the same for the fragment shader. Then we call create shader. There's some warning. Let's keep going, because maybe these are loaded by GLAD, I'm not really sure. But anyway, so we create a vertex shader, and then we say that the source to the shader is this thing that we just loaded, and then we compile it, do the same thing down here with the fragment shader. Then we turn it into a program, apparently, where you attach those shaders to the program, then you link it. Delete the shaders, you free the source. Okay, because it's allocated here, so we didn't free it again. That's fine. I'll return the shader program. So that looks fine. And then we can use this to create a program. So I don't know. Here it's also complaining about something, but this worked, so we'll let it be. Remember to call GL use program before drawing the shader program for rendering. So we create it, and then we need to use it somewhere. So where should I call that? Where should I call GL use program? You should call GL use program before issuing draw commands that require the specified shader program. Before issuing draw commands. Typically you call within your rendering loop after clearing the screen and setting up vertex buffers and other rendering stick, but before making draw calls. We don't have a draw call, but remember to call with the appropriate each draw call, especially with multiple shader. Okay, whatever. So first we clear it and set some background color basically. Then we set up vertex buffers, and then we say use program, use this guy, then we issue draw commands. So use program. We still need to figure out what to put here and what to put here. So how do I set up the vertex buffers? Okay, it's given us a long explanation. So set up the vertex buffers, follow these steps. So first we need some data. This stuff, I'm just gonna make it global. I think this works. Maybe we call it static. No, let's just do this. Generate a vertex buffer object and a vertex array object. So where do I do that? Where do I generate the VBO and the VAO? Okay, it's the initialization phase, so it's definitely in here. So we generate those before entering the rendering loop. Yes, this is because the VBO and VBO store data, which you only need to set up once if your geometry remains static. Okay, so we did that. Now let's copy this. So then we're saying use this buffer, or this vertex array rather. Then we're saying use this buffer. Then we're saying use this variable vertices as the data, and it's static, we'd never change it. And bind vertex array to 0. So now I think this 0 is this 0. And bind the buffer. Let's just for now see. Okay, so bind vertex, bind buffer, bind vertex array, bind buffer. Then buffer data we have. Then what is this thing? This thing we don't have. So it did not include that in this code, but that's fine. Okay, so here we are saying something. I am not gonna ask it about what all of this means because the video would take forever. But we're setting up position attributes, color attributes. Then we are unbinding. I don't know why we're doing that. So there's a lot of things you can ask. Why do we unbind? And like, what is the meaning of the input arguments? Things like that. And issue the draw command. So now you can use the VO draw. Within your rendering loop, bind the VAO. So let's try that. GL bind vertex array. And use the shader program, GL draw arrays. So it's some specific way of drawing. And after we draw, we have to unbind it. Interesting. So let's see if all this stuff actually works. We make it, bunch of warnings, and then we can try to run it. Did not work. Great. Could it be this somehow? Gonna try to move it inside the main function. I don't think that's it. So is it, let me try to change the color. Can I do make run? No. So let me do that. So we will say, how do you do that? Do you do, I don't know, make all and this thing? What was the error? Okay, whatever. Ah, is that why it's not building? Okay, there is. It's very nice that that's on top. And what is the problem? So grab. Okay, so after a lot of fiddling around, I gave up and I asked ChatGPT, please fix my error. And actually, the problem was that the includes were in the wrong order. So like, yeah, it's very nice to see. And now it works. So we can, first of all, we can clean. So then we can try to run a fresh make. And then we run the program. And it actually draws a triangle. Isn't that amazing? So I think the key takeaway here is like ChatGPT is quite a nice way to explore something, or learn something new, because I can ask about exactly what I'm interested in. The risk is that this learning becomes very unstructured because there's no teacher to provide like a good progression, a good structure, and explain the concepts in the right order. Or in a good order, which I think is useful sometimes at least. So I don't know, I actually quite like this approach, but you have to then, like, I don't think this is enough for learning. You have to afterwards write some notes, put what you learned into some kind of structure so it sticks better. But this for sure is like one of my favorite use cases for ChatGPT so far. So anyway, I will see you in the next one.